Hello lads and lasses. Welcome to Malfa Data's SAT tutorials. In this video, I'll be going over domain 4, our last one, which is over geometry and trigonometry. You can type in the link at the top of the screens for the slides, but I'll also leave it in the description. Real quick, there are also QR codes to different resources you can use. Of course, the questions and answer key are on the left. There's also a link to the College Board Desmos, which is the specific version you can use on the SAT. And I have this pulled up on the right here. And there's also some notes that I typed up. Let's go ahead and get started. These are the topics that we'll be going over. If you were in person, this is how the slides would work. I would go through certain questions, and any marked with a cow would be ones you can try out yourself. Since this is online, I'll obviously be going through every single question. Feel free to follow along or try some out on your own. There's also this form that you would fill out, but once again, I'll be going through all of them anyways, so you don't need to fill this out. Here we go with our first topic and question. They give us the volume of a cube, and they want us to find the surface area. Real quick, let's look at our notes. At the very bottom, you'll have this reference sheet, and this exact reference sheet will also be on the SAT. If you look at the bottom left, that's the volume of a rectangular prism, the formula for it. We know that in a cube, the length, width, and height are all equal, so really, the volume of a cube would just be a side length cubed. Alright, let's go ahead and just substitute in the volume. And then to solve for the length of a side, we would just take the cube root of both sides. We can put this in Desmos. To get cube root, you just type in CBRT, and then let's type in our volume. And we get that the length of one side is 78. Now to find the surface area, I did give you the formula right here. It's just 6 times s squared. Now if you didn't know that, here's a cube. It has 1, 2, 3, 4, 5, and 6 faces. So you do 6 times. And then the area of one of these faces would just be length times width, which is just s squared. So that's how you get that formula. Alright, let's go ahead and plot this in Desmos. 6 times 78 squared. We get our answer will be 64,000, I don't know what I'm saying, 36,504. So line number 7, this time we're going backwards. They give us the surface area, and we want to find the volume. Once again, the surface area of a cube is just 6s squared, and this is also equal to 54. Now let's go ahead and solve for s. Divide 6 from both sides to get 9, and then square root to get 3. Then we also know that the volume of a cube is just equal to s cubed, so that would be 3 cubed, which is 27. So that means our answer will be B. So line number 8. Here they give us a scale factor. They tell us that square A has side lengths that are 166 times larger or longer than the side lengths of square B. Then they want us to find the ratio between the areas of square A and square B, the value of K. Let's take a quick look at the notes. Whenever they give you the scale factor, all you have to do is square it, so multiply by itself or put it to the power of 2, to find out how many times larger the area is. And the reason this works is because of this proportion up here. Now I don't want to explain it, just know that it's going to be that easy. All we have to do is square 166 to find the value of K. Let's go ahead and do that. Our answer will be 27,556, just like that. So line number 9, once again we get that scale factor, and they want us to find the ratio between the two areas. Remember, all you gotta do is take this number and square it. So we get that our answer will be 60,516, which is A. Now we're moving on into our next topic. Let's get started with slide number 11. Here they tell us that two triangles are congruent. It says that A corresponds to D, which means that they'll both be in the same spot, and B and E are right angles, so we have two right triangles. Alright, I went ahead and drew in our triangles. We note that B and E are right angles, so this would be B and this would be E. Let me draw the right angles as well. We also know that A corresponds to D, so I'll just put A at the top, and then D would go in the same spot. And let's go ahead and finish out our triangle. It's triangle ABC, and then DEF. We know that the measure of angle A is 69 degrees. Oh, how exciting. And here's the thing about corresponding triangles. Corresponding angles are congruent. So basically, they have the exact same measure. If A has a measure of 69 degrees, D will also have a measure of 69 degrees. Now we need to find the measure of angle F down here. Of course, you should know that all the angles in a triangle add up to 180 degrees. So if we look at our right triangle over here, wait, they're both right triangles. If we look at triangle DEF, we would have angle F, or just X, plus our right angle, 90 degrees, plus angle D, 69 degrees, and this is equal to 180. Now to solve for angle F, or X, we just need to subtract 90 and 69 from 180. And we get our answer would be 21 degrees. The line number 12, we have two right triangles that are similar. So here's our two triangles. We note that L and M correspond to P and Q respectively. So basically, L would correspond to P and M would correspond to Q. Let's go ahead and write that. L is P, and then M is Q. Now they don't tell us which angle is the right angle, so I don't think it matters where we put it. Well, actually, I know it does not matter because I could never be wrong. Alright, and let's just go ahead and finish up our triangle. This would be N and this would be R. They tell us that angle M has a measure of 53 degrees. Dang, I was wrong. Alright, that's rough. Alright, so all I did was swap the two angles on the bottom here. We know that M is 53 degrees, and they want us to find the measure of angle Q. Would you look at that? They're both in the same spot. And you'll know what that means. They both have the same measure. So that means our answer would be 53 degrees, or B. So line number 13, here we have two parallel lines and a transversal, or a line that goes through both of them. They tell us that y is equal to 2x plus 8. So I'm going to write that down, 2x plus 8. And they want us to find the value of x. Quick geometry refresher, if we look at the notes, here are all the congruent and supplementary angles in all their cases. But I'm lazy and I don't want to go through all of them. So let me just show you what I would do to get this answer in this question specifically. So these two angles are a vertical pair because they're across from each other, and that means they have the same measure. So this is also 58 degrees. And then these two are on the same side, so they would add up to 180 degrees. So we would know that 58 plus 2x plus 8 is equal to 180. And now we just need to solve for x. Alright, that would just be 180 minus 58 minus 8. And then get that and divide it by 2. And we get that x would be 57 degrees. Well, I guess it's not degrees, it's just 57. So line number 14, once again another set of parallel lines with a transversal. They tell us that x is equal to 6k plus 13. I forgot to change my color, and then y is equal to 8k minus 29. Then they want us to find the value of z. Somehow this managed to be the exact same process as the last question, because we have vertical pair, so they're equal to each other, and then consecutive interior angles, so they add up to 180. Alright, once again, x and y are across from each other, so they're equal. Alright, let's get k by itself. And then divide by 2 to get that k is equal to 21. But job's not done yet, don't choose 21. Now we know that y and z are supplementary angles, so they add up to 180. And then let's substitute in 21 for k. Alright, and now finally we can solve for z. That's just gonna be 180 minus 8 times 21 plus 29. And we get that z would be equal to 41 degrees, which is C. Now we're moving on into our next topic. Let's get started with slide number 16. We're given a right triangle and they want us to find the length of side PQ. Here's P, here's Q, so we're trying to find this side right here. I tried highlighting it, it kind of looks chopped. Normally you would think, oh, let's just use Pythagorean theorem because it's a right triangle and we're trying to find the missing side length. The problem with that is that we only have one side. We need two sides for Pythagorean theorem because you need either both legs or one leg and the hypotenuse. Instead, we're going to be using SOHCAHTOA, which is these right here, and hopefully you remember all of these. If you didn't, I did write them down, of course, in the notes. So here's our angle, and the two sides we have are the ones across from it, so the opposite, as well as the hypotenuse. So we have the opposite and the hypotenuse. Oh my goodness, we're going to be using sine. So it's going to be sine of the angle, which is 30 degrees, is equal to the opposite, that's just x, over the hypotenuse, which is 8. Now to get x by itself, we're going to multiply by 8 on both sides to get 8 sine of 30 is equal to x. And we can just plug that straight into Desmos. 8 sine 30. And this should be an indicator because the side length of a triangle should not be negative. So make sure that the calculator is in degree mode. Let's click this top right icon right here. And would you look at that, it's in radians. That's bad. We want to change that to degrees. And we get that our side length would be 4. And that sounds a lot better. So line number 17. Once again, we're given a right triangle. And they want us to find the missing side length. Here's A, here's D, so they want us to find this side right here. You should notice that there's a 30-degree angle, a 60-degree angle, and a 90-degree angle, which means you have a 30, 60, 90 triangle, special right triangle. If we look at the notes, you'll see that special right triangles are also on the reference sheet, so you don't need to memorize those. They're up here on the top right, and of course on the left is the one we want. The 30, 60, 90 triangle. We know that across from the right angle is the 2x. So here 12 would be equal to 2x. And then across from the 30-degree angle would be just x. So would you look at that? We already got it done. I think you can tell where we're going to go from here. Let's just find the value of x. Obviously it's just 6. And then that's also what we're trying to find. So our answer will be 6. Now just like our previous question, you could use SOHCAHTOA by moving the 12 over here and then doing 12 sine 30, that would also get you 6. So line number 18, here they give us a right triangle with two congruent sides, so that would be a right isosceles triangle, and if you remember anything from geometry, that is a special right triangle. It's the one on the right here, well the very top right. It's the 45, 45, 90 triangle. The two legs would be equal to each other, and in this case, it is. The two angles would then be 45 degrees, and then the hypotenuse would just be the side length of the leg times the square root of 2. In this case, they're asking us for the value of x, which is one of the degrees, so that means our answer would just be 45. X is equal to 45. So line number 19, here they give us a right triangle with two side lengths and they want us to find the missing one. This time we will be using that Pythagorean theorem. If we look at our notes, the Pythagorean theorem is just a squared plus b squared is equal to c squared, where a and b are the legs and c is the hypotenuse. Here we would have a as a leg, so that's just a squared, and then 6 is another leg, so that would be our b, or 6 squared, and that would be equal to our hypotenuse, which is c squared. Now they want us to represent the value of a, which basically means get a by itself. So we have to subtract the 6 squared to the other side. And then to get rid of the square right here, we need to take the square root of both sides. And we get a is equal to the square root of 21 squared minus 6 squared, which is a. Wait, a is a. Oh my goodness. So line number 20. They give us a right triangle and want us to find the value of the tangent of A. So SOHCAHTOA, tangent is gonna be opposite over adjacent. So here's angle A, and we want the opposite over the adjacent. Our answer would just be 20 over 21. Now when they ask you to find this value, you do not need to put it in decimals, y'all. You don't need to put the tangent of 20 over 21, just the fraction itself. Slide number 21, they give us a right triangle and want us to find the cosine of A. So Katoa cosine is gonna be the adjacent over the hypotenuse. If we look at our triangle, here's angle A, the adjacent is 41, and the hypotenuse is 42. Adjacent over hypotenuse is gonna be 41 over 42, and this will be our answer. Slide number 22, here they give us a right triangle and want us to find the value of the sine of x. So Katoa sine is gonna be opposite over hypotenuse. Here's angle x, here's our opposite, and here's our hypotenuse. Opposite over hypotenuse is gonna be 16 over 23, and that will be our answer. Now we're moving on into our last topic. Let's get started with slide number 24. They give us the measure of an angle in radians and want us to convert it to degrees. If we take a quick look at the notes, here is the radian degree conversion. Now you actually don't need to memorize this if you don't want to. All you need to remember is that 180 degrees is equal to 1 pi. Now let's go back to our question. You notice that the pi is on the top of the fraction in the number we're given. So when we multiply by 180 and pi, we want to make sure the pi is on the bottom. We want them to be diagonal from each other so they cancel out. And put that 180 on top. Now if it was the other way around and we had 9 over 20 pi, then you would want to multiply by pi over 180, so the 2 pi's would cancel out. Just saying. Now we can just go ahead and put this into decimals. And we get our answer would be 81 degrees. Slide number 25, once again we're given an angle in radians and they want us to convert it to degrees. I don't know why I didn't find one that wanted me to convert to radians. I don't know what I was doing when I made this. But anyways, we want the pi to be diagonal from each other, so it's going to be on the bottom and 180 will be on the top. Now we just need to put this into decimals. I forgot to mention this, but you can either click the pi symbol at the bottom or just type in pi. And we get our answer would be 192 degrees. Slide number 26. Here they give us an equation of a circle and they want us to find the coordinates of the center of the circle. If we take a look at our notes, coordinates of the center, the first thing we want to do is plug that equation into decimals. Now when you type this, you want to type it exactly as it is, including the equal 0 in the same line. And here is our beautiful circle. Now our next step is to find the coordinates of the two endpoints. Now if we click on the circle, we would have our two endpoints right here, and we'd also have our two endpoints right here. You can use any of them, but since I already have this one up, I guess we'll be using this one. Now what you want to do is just go ahead and click export point and export point. And now we want to type in midpoint, parentheses, and now we want to put in the two coordinates of the two endpoints. So we already put this down here. I'm going to just copy and paste them. Between them, you want to put a comma, and then the second one. And here's our midpoint, which is also, as you can tell, the center of the circle. That means our answer would be D. Slide number 27. Once again, we are given an equation of a circle and we want to find the center. First thing you want to do, just type that equation into decimals. Alright, here is our circle. Now we want to find our two endpoints. So we're going to click on the circle. Now be careful. These two are not endpoints. They're just x-intercepts. These two are also not endpoints. They're just y-intercepts. Now these two, these would be our endpoints. So we want to go ahead and export these. And then type in midpoint, parentheses. Copy and paste these two. Put a comma between. Here's our second one. And we get that the center of our circle would be -10, -8. Which means our answer is B. Slide number 28. We're given an equation of a circle, but this time they want us to find the length of the radius. Let's take a quick look at the notes. Here is the radius of a circle. And just like before, you're going to type the equation into Desmos and find the midpoint. Let's go ahead and do that. Here's our beautiful circle. Now especially be careful. This is not the endpoint. This is. And same thing down here. So you want to use the point that's slightly to the left of that. And let's go ahead and export these two. Now we're going to find the midpoint by typing in midpoint. And then copy and paste these 2 points. Oh, I don't even know what I just did. Put a comma between them. Wait, this is low-key kind of nice. Wait, I probably should have had it on this. That's whatever. So here's our midpoint. And now our next step is to find the distance between the midpoint and one of our endpoints. So we're going to type in distance. And then our first point will be the midpoint. So we can just copy that. Put a comma. And then now we can choose either one of our endpoints. It wouldn't matter. I'll just use this bottom one. And we get that the length of the radius would be 10. So that means our answer will be 10. Now that's the way I wrote in the notes, but there is also a second way. You can just do distance and then put in your 2 endpoints, comma between them. Now this would be the distance between the 2 endpoints, which is the diameter. But you should know that the radius is just half the diameter, so you just divide that by 2, and once again you would get 10. Slide number 29. Once again, we're given an equation of a circle, but this time they want us to find out which of the points are not inside the circle. This one is actually pretty straightforward. First we need to type in our equation, of course. Alright, and now we just need to type in all of our answer choices, and whichever one is outside the circle will be our answer. I like to label my points because it's easier to see. This is obviously inside the circle, so A isn't going to be our answer. Here's B, inside the circle, not our answer. Here's E, inside our circle, not the answer. It's obviously going to be D because it's the only one left, but if we check, it is outside the circle. Now these are some extra questions that I included at the end in case we had extra time at tutorials. Since this is online, I'll be going through them as well. Let's get started with slide number 31. They give us the volume of a right circular cylinder, and they also give us the height. Now they want us to find the radius. If we look at our reference sheet real quick, you'll know that the volume of a right circular cylinder is, it's the second shape on the bottom here, pi r squared times the height. Now we know that the volume is 45 pi, and we also know that the height is 5. Now we just need to solve for r. We know that the pi's will cancel out. 45 divided by 5 is 9, and then the square root of 9 is 3. So our answer will be A. Slide number 32. Here they give us a right triangle and they ask us for the area. I don't think we need to take a look at the notes for this one, but just in case, the area of a triangle is on the reference sheet. It's the third shape at the very top. Area is equal to 1/2 times base times height. So area is equal to 1/2. The base would be 5 and the height would be 3. Let's go ahead and put this in Desmos, and we get our answer would be 7.5 square inches. Slide number 33. They ask us for the volume of a 4x9x10 right rectangular prism. Once again, looking at the notes, it's at the very bottom left. The volume of a right rectangular prism is length times width times height. So here the volume would just be 4 times 9 times 10. And our answer would be 360. Slide number 34. They want us to find the volume of a cube with side lengths of 41 inches. Once again, the volume is just length times width times height. But since the lengths, widths, and heights of a cube are all equal, it would really just be that side length cubed. So that would just be 41 cubed, which means our answer is probably D because every other number is too small. But just to check in Desmos, it is. So once again, our answer is D. Alright, that concludes all the questions I have for Mu Alpha Theta's tutorials on Domain 4, Geometry and Trigonometry. If you would like to get more practice on harder questions, please check out my SAT doc. Real quick, let me show you how to use it. Of course, you would click on Math, and then our fourth domain, Geometry and Trigonometry. And just like the slides and the questions, it's broken up by topic. There's the questions, answer key, and a video that goes through all the questions. That's gonna be it. Good luck studying, and I'll see ya. Min out.